Alright guys, today we're going to be battling. We've got the OEM wind versus the group wind versus the pair wind versus the single coil wind. Alright, and we're going to do this by making sense. First of all, let's start off with the OEM. Alright, so the OEM motor is wound with 7 coils. Alright, so let's take a look at this. Here is the south magnet, and here's the north magnet. Alright, and here is the bisector of each stator. Alright, so let's count it out. Alright, 1, 2, 3, 4, 5, 6, 7. 7 poles right here. And this one is where the coils will be joined together, because we've got another 7 to go. 1, 2, 3, 4, 5, 6, 7. Okay, now if we look at it, this one right here is the 4th pole. Alright, and this one is the 4th pole for the OEM motors. Now, we all know that this coil is pretty lengthy to cover all these poles, but the way they have it positioned is 5 degrees past the stator bisector, which is usual. Alright, but the coil length is extremely long. Alright, and what that does is it causes voltage drop. Alright, and furthermore, the way that they have the north and south wind, it causes the CMF to build up right around here, and it's pretty strong, so it takes away also. Alright, so you can't achieve that extremely high RPMs like you've seen with the group winds and the pair winds. Alright, so let's take a look. Now, the first motors that we had wound, the first motor that I wound was the north-south asymmetric motor, and we used the same concept as the OEM motor. We wound it 7, and then we did it. Well, actually, we wound it 7, but we shared this space here, so it was wound the same way. So the torque was extremely good on our asymmetric motors. Not to mention, we use 3 times the copper. Okay, and we do get an unfair advantage because the CMF in our motor is drastically reduced. Alright, so the torque, if you went coil turns for coil turns at the same gauge and the same gauge, they would basically be a fair fight, you know, give or take, but they would both do their same. They would both be strong contenders. Now, if you took the pair wind, okay, you took the pair wind, you know, let's see here. We got 1, 2, excuse me, 1, what is he doing? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Because it has to be finished there. So back. Alright. Alright. So he's using 5 and 5. Alright. So 1, 2, 3. Past the bisector. 4, 5. Alright. They're sharing here. So 1, 2, 3. So it's ending right here. 4, 5. Alright. So, but this coil right here, it's in the attract mode, alright, and it's starting right around here, alright, so it has to travel all the way through this empty space before it starts to gain any strength before it hits around here. So common sense would tell you that the pair winds on the asymmetric motors would be weaker than the Imperial OEM motor. The reason why is because we've got stator bisector here and a stator bisector here, and the OEM motor is firing here, and it's firing here and here, excuse me, and the asymmetric pair wind is firing here and it's firing here. All right, I don't know about you, but there ain't no magnets here. There's nothing happening here, people. There is 0 force here. So common sense would tell you it's not going to have the same torque wire gauge for wire gauge, watt for watt, voltage for voltage turn for turn. So that's why I said, that ain't gonna do it either. Now the group wounds, that's a complete joke. It's a complete joke. All right, you got a mess all up in here, and the most of the coils, they're right here. This is the max density right here of the whole entire thing. All right, so let's think about that, people. If the max density is right here, 1 + 1, there's no magnet here, people. There is 0 magnet there. Okay, I'm not a magician. There ain't no magnetic. There's nothing there. The group wins is garbage. Now let's get into it with the A1Mo-Gen. That makes sense. All right. Now the A1Mo-Gen, the coils must be the same size as your stator, the magnet. All right. So it's approximately 1, 2, 3, 4, 5. There's 5 of them. All right. And on the bottom, 1, 2, 3, 4, 5. Now, if you look here, here would be 5 degrees past the stator bisector, which would be this one right here. All right. So at every input, 1, 2, 3, 4 inputs, they're all firing 5 degrees past the stator bisector. And look how concentrated it is next to the stator. Now, we need to think about voltage drop also. Now, since we have a very tight consecutive wind, the voltage drop is minimized. Okay, why? Because the coil is shorter. It doesn't have to travel very far. And it's right here concentrated 5 degrees after the stator bisector. Okay, so this all makes sense. And when I tried the A1Mo-Gen the other day with the 4 coils, the RPMs jumped compared to the 2 inputs, and I was surprised about that. And I listened to the RPMs of the pair winds when we did the pair winds north-south, and the pair winds of this one, the sound was pretty close. Now, we figured out about where the magnetic strength is, but now we need to have this fair. Okay, and we're going to go against the OEM. All right, because the asymmetric north-south wind, the amperes is through the roof and it sparks like hell. You don't need it. All right, so if we took the OEM motor and we did our 7, 1, 2, 3, 4, 5, 6, 7. Your 4th one is here, and your 4th one is here, 7. Okay, all right, and they're tying off in here somewhere. I think this one, and that coil is really long. All right, and it's 8 turns here of 16 gauge wire, and 8 turns here of 16 gauge wire. We need a fair battle here. Okay, and they have 1 input. All right, so let's go to the A1Mo-Gen, and we're going to use 1 input also, because this has to be a fair battle now. We're going to use the 5 coils, the 5 poles as usual, 1, 2, 3, 4, 5. All right, and we're going to wind this one 16 turns. The reason why is because they got 1 input, and they've got 8 turns here and 8 turns here for the OEM. That's 16 turns. Okay, so we got to have a fair fight. I get 16 turns also on my motor. All right, so I get 16 turns on the A1Mo-Gen, Tesla's electromagnetic reactor. We get 16 turns here. I used the calculator a while back, and I found out if you use, let's say, the 16 gauge wire, if you use 8 turns of 16 gauge wire versus 16 turns of, what is it? I'm getting lost. 16 turns of 16 gauge wire versus 8 turns of 16 gauge wire. The 16 gauge wire is extremely stronger than the 8-1. It doesn't double, it more than doubles. Okay? Now, so for example, for the OEM motor, if you went here with 8 turns and 8 turns, let's give it a nominal value of 10. Okay? So you've got 10 here and 10 here. That equals 20. Now, if you do the 16 turns here, this would equal 30. Aha! This is where the magic of the single coil turns the turn on all situations. Not only is the magnetic torque stronger, the voltage drop is a lot less. Furthermore, the CEM has been reduced drastically due to the asymmetric winds that Tesla created. Now, I'm just a regular guy, and I could be wrong, but common sense tells me I'm not, plus some calculators. So you do the math, you sit back and you think about it, and tell me whether or not the A1Mo-Gen, which I fondly call her, or when you do her up really well and you put the larger commutators on it, Tesla's electromagnetic reactor, the OEM does not stand a chance. Keep it clean and green, Midas.